My ramblings. I'm going to call this code checking part two. Um, in the previous version, I talked about a lot of different topics. How the Navy isn't the code checking responsibility party for work we get from A&E's, architects and engineering firms, or for construction contractors. Um, but there are checks done with the purpose of looking after the Navy's interest. You know, are we getting what we contracted for? Are they meeting the scope of work? You know, and spot checks would be done for code and stuff. But where this really was meant to go is, um, you know, if the Navy wants to say, hey, okay, um, you know, I'd rather pay as little as I can, so you know, I won't have anything in my criteria saying make this panel have a short circuit rating, close or double what the available short circuit current is. Um, that's an owner's decision. That's not something that falls to a contractor, whether a designer or a construction guy. Because really, that's an economic analysis, an economic assessment. The problem is, though, is although there's nothing from the higher command saying you will not go beyond the NEC requirements, there's, in the debate that went on, there's far too many people that weren't electrical engineers, and we had electrical engineers come in from the outside, and they seemed to, I guess they were used to just complying mainly with the minimum NEC requirements. But I guess there was just too many people saying, "Hey, the NEC is all you require. It's a minimum standard. Why shouldn't the minimum be enough?" It was actually something somebody said to me once. But the problem is now you've created a rather large administrative effort that you need to undertake because I think Kingsville had 88 um, buildings or facilities. I was doing an investigation. We had a problem where the available short circuit was actually more than the ratings, and that was like 8-10 month project I worked on. One of the bases had 255 buildings. San Diego probably has 1,000 buildings. You know, so if you're just if engineers will select various short circuit ratings for the equipment. It's just kind of, that's some engineers want a little extra safety margin. It just really depends. But if, if there's not like in the criteria that, we'll use double, then, you're into that one standard thing that I was talking about. I think it's AB1. I don't really remember. It's a Nema standard. It's a standard that describes what circuit breakers are designed and built. And they have standards for everything. And I'll talk about basis of design if I have time. But it says that, this breaker is only designed and manufactured to withstand 2 trips near its maximum short circuit rating. And so it's sort of a business decision. Am I willing to take that? And then, knowing that somewhere down the road, if I may have to replace these breakers, maybe there never will be a short circuit um, through those breakers. Then it's not an issue. But when you talk about the way that thing was designed to be made and used, oh, once it sees once it interrupts 2 short circuits near its um, maximum short circuit rating, the thing is not guaranteed to work. So you're sort of leaving it to chance whether that breaker um, hasn't degraded to the point where it's not going to be able to perform its function and trip open on maybe any level of fault. And so, do you just leave it out there and go fight the fire when it happens, or pay workman's comp and medical bills if somebody gets shocked or electrocuted. Um, I mean, that kind of stuff doesn't happen that often, but it could. So you could envision, well, as part of the business decision to comply with the minimum NEC and to keep costs down, to push that short circuit rating as low as you can. And well, now you have a huge administrative effort because you have to track all your circuit breakers now. You have to track your circuit breakers. When a fault occurs, that has to be reported to somebody. Somebody has to investigate the fault, identify where it was, determine what was the probable short circuit current that flew through it, and then keep track of how many times the breaker tripped, so that you knew that, well, if when it has those two faults that it interrupts, that now you have to replace it. And then you got to, if we had one mechanical engineer I could cite as a anecdotal story. He was saying, I have, for some reason this motor keeps overloading. It's protected by some internal things, and that meets the minimum requirements of the code. But every year I have to replace the motor because although the devices meeting the code prevent the fire, um, it doesn't prevent the equipment from melting down and not being usable a second time. So you have to keep extra spare parts on hand and stuff, um, just in case there's a fault. And then you don't create a fire, but your motor doesn't burn up. I guess you could order it to keep the equipment, you know, non-operational while you place the order and hope they have it in stock and then it comes in. Usually, the Navy, at least, in the shops, they always kept spare parts on hand for stuff that was more likely to fail. So, you know, um, it's just an interesting point that I thought I'd bring up. So, and talking about, current flowing through these breaks. When I was in, usually in facilities engineering, you would get sent to a training course once a year to help advance your knowledge, to expand it. For some reason they switched up and said, hey, we're not going to do that no more. We got to make sure all our contracting officers and contract specialists are trained. And so they sort of cut that off in PwC San Diego. But when I was in the internship, I think, and I think I called it Professional Development Corporation. It was actually Professional Development Center. I think they were sending us to 2 courses or more, depending, I don't know. But one of them was Industrial Systems Analysis. And this course focused on a lot of things, but with regard to faults, it focused on balance faults. If you have a 3-phase system, same amount of current flowing through, it's called a balance fault. In the modern power system classes I was taking, it was a 3-part series. We were much more comprehensive than that. They covered balanced and unbalanced situations. But the class also did a lot on equipment protection, drawing transformer damage curves and other equipment curves and what have you. And while we covered a little bit of that, it was just a whole broader spectrum that we covered in the university courses. And we did cover protective devices and stuff like that. In this class, we actually did we actually went through workshops of doing equipment protection and stuff. And I think we actually did a protective device coordination study for a system. But one of the most important things was basis of ratings. And it kind of starts off with, the asymmetrical component of waveforms after switching. And this is mainly due to the inductive reactance that you find in practical electrical systems, building electrical systems. Oh, excuse me. And it's asymmetrical because you have a symmetrical or the AC component, and then you have a DC offset. And a lot of equipment and stuff used to be based on asymmetrical, but then it switched to being symmetrical with some assumption for what the X to R ratio was. The X to R ratio is less than this, then these ratings apply. It goes a little bit further. We did a lot of stuff that um, was covered in some of the books my supervisory electrical engineer gave me, and some of the stuff we were learning at the university, cable damage curves and just so on and so forth. But there's also a standards-based component to it, and I guess the thing that you walk away from learning there is that although there are standards like IEEE standards that manufacturers meet, a lot of the standards that equipment are designed and manufactured to are Nema standards. And I guess the walk away from all of that, well, if you don't understand the basis on which this stuff was designed, how it was meant to be applied, what the ratings mean, there's just all kinds of tons that you can't really properly and safely apply the equipment. And so the circuit breakers AB1, I think it was, is one of the things I had got to when we had our senior engineer, junior engineer, junior engineer arrangement. Had a lot more time to investigate that because we had the standards database and we had other resources. When we got moved out, really didn't have any resources to utilize, and there's internet stuff, but it's like walking into a library without a library indexing system. It's not very efficient for the first thing. And anyway, so that's this episode. There was just a couple of things I wanted to speak to. And so, as you can see, this is going, it's already 12 minutes. Take chapters and chapters. Not that I'm going to spend chapters and chapters. I might on the basis of design. Anyway, hope you enjoyed the episode, and tune in.